Hey people, welcome back. And in this session, we will be learning about the Moore's median test. So Moore's median test we use when you are comparing two plus group of the data and the measure of central tendency is median. Median we compare when your data is not meeting the assumption of a normally distributed data. So which means your data is non-normal, which means data is not a parametric data, it's a non-parametric data. Then we use the Moore's median test. So the principle of the Moore's median test works like as suppose you have a median of the data is set is 1 is here. Maybe the median of data 2 is here, or maybe the median of data set 3 is here. So if you look for the mathematical value of all three data set is different from each other. But I will be comparing this with the confidence interval. And if this is the confidence interval for the data set 1, like this, and suppose that confidence interval for the data set 2 is maybe here, which is for the green one, second data set, and the confidence interval for the data set 3 is somewhere here, which is the blue data set. So now, if you look from this data perspective, you can see blue and green are overlapping at a point here. So they are same statistically, mathematically, their value is this versus value is this. So you can see they are different. But statistically, they are not different because their confidence interval is overlapping. Similar way, if you look for the green and blue, the confidence interval is overlapping, so they are same. But if you compare the blue versus orange, the confidence interval is on the upper side for the orange is here and the lower side of the blue is here. So there is a clear gap created between blue and orange. So they are different. So when we say the null hypothesis assumption, for me as a Moore's median test, null hypothesis will say all medians are same. Null hypothesis, all median are same. While the alternate hypothesis will say at least one median is different. So in case my p-value come less than 0.05, so we have to identify which median is different. If my p-value is greater than 0.05, which means statistically all the medians are same. So let's do this with an example. Maybe I will pick up the example of, let's say, the number of transactions done by the team for the team 1. Here is the team 2. You have team 3. You have team 4. And here is the team 5. Let's say you wanted to compare 5 team leaders are there in your team. You wanted to compare the production what all these 5 teams are doing with respect to the number of transactions. Are they same or are they different? We will assume data is not normal. So let's say the team 1 on a day is doing the transaction maybe around, let's say, 40 to 50 transaction on an average. Team 2 done the transaction around, let's say, 45 with a less variation to maybe around 51. Team 3 is doing a transaction on the little higher side, just assuming, let's say, around 55 minimum to going up to, let's say, 62. Team 3 is doing some transaction, maybe approximately, let's say, 45 to 55. And the another team is doing some transaction, maybe around, let's say, 48, just random number, to 55. And the 5 team data you have for 1 month data, which means you have 125 sample for that. 5 into 25 is 125. And this is your 125 sample data we have here. Now I wanted to compare with respect to the count. Overall, are they doing the central tendency as in same with respect to the median or not? So median, the people who do not know, is the central value of the data when you arrange your data in ascending or descending order. So if I arrange this data, I will look for that what is the central value of the data. That is your median. So I wanted to compare the median of all these five teams are statistically same or different. For that, we perform the Moore's median test. Assumption is that the data is a non-parametric or the not normal data. We need not to worry checking or not checking. We are assuming not normal, but still if you want to check, I'll tell you how to check the normality of the data. So suppose here I'm putting up my data. I want to check the normality assumption. We'll go to the graph, probability plot. You can select single and you can select here like all the five teams. That's all. Maybe you look for the overlaid on the same graph or separate graph, whatever, and you will see the p-values for all of these five teams here, which will be based on the Anderson-Darling statistics. So first team, p-value 0.043, which means data is not normal. Second p-value 0.048, again data is not normal. Third p-value 0.041, data is not normally distributed. Fourth p-value is 0.016, data is not normally distributed. And fifth p-value is 0.226, which is greater than 0.05. Only one value out of five team is greater than 0.05, which means this data is normally distributed, right? So my assumption, my data is not normally distributed. I wanted to compare the median of that. So how to perform the Moore's median test? We'll go to the stat. We'll go to the non-parametric. And in non-parametric, I will be selecting the Moore's median test here. Click on this. Oh, there is a one problem. In this version of Minitab, it is asking response in one column and the factor in the other column. But my response and the factor are in different columns. So I have to arrange this. So Minitab gives you one option to stack your data. Suppose here I select, this is your response. Response will be the value. And here is the factor. Factor means the team 1, team 2, team 3, team 4 or team 5. I'll go to the data. In data, I'll select the stack and stack the columns. In columns, I will be selecting all of these five columns, where in the column of the current worksheet, the response I want to record in the response column I named already, and the factor I want to record or subscript in the factor column. That's all. And you will see that your data is arranged with the value as well as the factor for all the five teams. So stack column is very powerful. You can stack any data. Similar way as I stacked, you can unstack as well. So unstack option is also there, which is this column. So you can unstack the column where you want to unstack. Now I'll go to stat, non-parametric, Moore's median. Moore's median test was discovered with Mr. John Moore in 1950. Just for the information. So response here is response and the factor here is factor. Click on OK and here are the result. So what I look for the first thing I look for the p-value. P-value is less than 0.05, which means the data what I have does not have the equal medians. If you look for the equal medians of the data, which is 45, 49, 59, 48, and 52, overall is 50. So these all medians, at least one median is different from other. Which one is other? You will look for the confidence interval for the median, whichever is not overlapping, that is different from the other. So we will look for the p-value first thing. If p-value is less than 0.05, then we'll look for the confidence interval. If p-value is greater than 0.05, which means all the median are same, we need not to worry. But if the p-value is less than 0.05, at least one median is different from other. Which median is different, we will be looking from here. And that's how we do the Moore's median test. Thank you so much, people, and I'll see you in the next session.